Hello everyone, this is Teja. In this video, I am going to explain about my lab exercise 2, that is optimization of Brissenham's algorithm in computer graphics and multimedia. So, what is actually a line drawing algorithm? A line drawing algorithm is used to display a line in a graphical mode. So, as we know that the graphic driver is in a discrete space, so we can consider only a unit point. So we have to round off the points between one point and one point, so we have to approximately get a line in those pixels. So in this algorithm I am going to explain how, using one starting point and ending point, how am I going to draw my line approximately equal to the actual line. So let's get started. In line drawing algorithm, we will getting a 2 points as inputs. One is starting point coordinates and ending point coordinates. With that point, I am going to calculate my distance between them. So distance, not actually the distance between x1 and x2. So that I am going to divide the x coordinates into unit. Like suppose the difference between x1 and x2 is 5. So I am going to divide the line into 5 pieces. So in that 5 pieces, what am I going to do is, I am going to calculate the unit distance. As we know that is going to be unit distance equal unit distance. So I can use the parametric equation here. See, now calculate the approximate distance between first given input and then intermediate input device. And I am going to, okay, let's keep that aside, and I'm going to show how to get the angle of the line. As we know that tan theta equal to m equal to y2 minus y1 by x2 minus x1, so we can get the angle theta, and then I am going to increment the value in I in for condition and keep incrementing the coordinates by using parametric form of axis method. Like parametric equation, you write x equal to x plus r cos theta. R means distance. Using that equation, before I told that we are divided this line into unit pieces. So each you know the distance, and r is the distance, you know the theta. So x equal to x dash equal to x plus r cos theta. So we can find the point which is at unit distance from the required point. So using that, and here the for loop is used to like find the all points before the ending, before the end point. So this is the idea. So the equation that he projected here is x1 equal to x1 plus dx by d by x cos into theta, y1 equal to, that we discussed earlier. Now here the intermediate points will be increment points of x1 and y1. So the points will get increases only using the x1, because we have to consider either x1 or y1 to increase, so that we will be going in a line to get the points we will settle. So we used this algorithm and we got the approximate line, so that we can see the points in later software. My teammate Sushant will continue the video.
Hello, I'm Sushant. As my teammate already explained the algorithm of the optimization of Brissenham's algorithm, which we tried from our side, now I'm going to explain you the code. The code actually are written in Dev C++. So now first we take initialize all the coordinates in the double integer data type. Now we give inputs of all the coordinates, and then we calculate the difference between the x coordinates of the inputs, which is double type C. Now we find the distance between those coordinates and divide it by C to get the distance between the first input and the next intermediate point. Now we calculate the the angle in the form of radians by calculating in the form of inverse tan, which is given as a tan in C++, and y2 minus y1 by x minus the slope, which we get the angle of the line which is made with the x-axis. Now by using the for loop, by putting these conditions, we increment I from x1 the input coordinate to the final coordinate x2. Now we keep on incrementing x1 in the form of the translation parametric form of equations, which is x1 is equals to x1 plus d cos radians, and y1 is equals to y1 plus d sine radians. Now For the output, we convert this data type into int. We convert the double data type into int. Now we get the final coordinates in the form of x1 and y1. Now these are the outputs for just to measure the distance and the radians and the sine radians to get clarity about and the confirmation about it. That's it. Now let's compile this program. Sorry. So now, as the notice, the compilation time is very less, 2.25 seconds. I'm going to run the program. Now I'm going to give first x coordinate as an input, which is going to be now I'm going to try for the very large numbers, because for very large numbers this code is very optimized and very efficient and very accurate. So I'm going to try for 50, 40, 100 and 150. These are the intermediate points which I get as the output, which is accurate and efficient when compared to the very small pixel values. For the very large pixel values, this code is going to be very efficient, and the extra after 22 seconds, which is very less, and I get the radians and all the values, which is a pretty accurate. That's it. Thank you.